Hello friends, welcome back to my channel Chemistry with DB. So in this video I have explained the concept of polarization which leads to some covalent character occurring in the ionic compounds. Now first of all let's understand what is polarization. So polarization is basically the distortion of the electron cloud around an anion by a highly charged dense cation. So if this is the cation, then in that case, and this is the anion, then the electron cloud is distorted. That leads to polarization. If there is a greater charge density on the cation, then it's able to attract the electrons in the outermost shell of the anion, and as a result of this there is some electron sharing occurs in otherwise what it would have been in just a purely ionic bond. Now in order for polarization to occur, the cation should be highly polarizing, and when that happens, that will happen when cation is small and it has a high charge, or in other words it has a higher charge density. So for example, aluminium 3 plus ion would be more polarizing than the Na plus. And for the anion, it should be highly polarizable. And when that would happen? When it has a larger ionic radius and a higher charge. For example, I minus would be more polarizable than Cl minus. I have explained it further by taking an example of, let's say, aluminium iodide and sodium chloride. Aluminium ion is smaller than Na plus and it has a bigger charge. Therefore, Al3 plus is more polarizing. On the other hand, I minus is bigger, so which is the perfect condition for polarizability, than the Cl minus, and therefore, and they have the same charge, which is 1 minus, so therefore I minus is more polarizable. As a result of this, what will happen is when we look at aluminium iodide, aluminium is highly polarizing and I minus is highly polarizable. As a result of this, what you would observe is that this is the cation and this is the I minus, so there would be some polarization occurring. On the other hand, if we look at sodium chloride, so because sodium ion is not as polarizing and Cl minus is less polarizable, as a result these will be present as two perfect spheres or no polarization would happen. Now moving further, what is the effect of polarization? What happens on account of this? That the two ions no longer remain perfect spheres and some covalent character arises which makes the bond even stronger, and as a result the lattice enthalpy value becomes even more exothermic. Now the theoretical and experimental lattice enthalpy differences, these indicate whether a particular ionic compound has perfect ionic model or whether there is some covalent character. Now we have to look at the theoretical and experimental lattice enthalpy values and understand that if there is a difference in the two values, that means there is some covalent character or there is some polarization. Now let's look at the theoretical experimental lattice enthalpy values for sodium chloride and silver iodide. Sodium chloride experimental value is minus 782 and theoretical value is minus 781, which shows that there is hardly any difference, which indicates that there is a 100% ionic bond because there is no polarization occurring. In case of silver iodide, on the other hand, the experimental value is minus 889 and the theoretical value is minus 778, much less. And there is a difference of almost 14.3%, which indicates that it's no longer a pure 100% ionic bond. It's mainly ionic, but there is a significant covalent character also arising there. I hope this was you were able to understand this, and if you want a further explanation on the lattice enthalpy of ionic compounds, or if we'll have to look at the continuum of the ionic and covalent bonding which occurs in different types of compounds, then you can watch further videos in this series. The link I will give in the description box below. So thank you so much for watching this video, and I look forward to see you on my next video. Bye. Take care.